We're looking at homework from section 4.3. This is question number 9. Find the indicated probabilities using the geometric distribution, the Poisson distribution, or the binomial distribution. Then determine if the events are unusual. If convenient, use the appropriate probability table or technology to find the probabilities. 56% of adults say they have cheated on a test or exam before. You randomly select 7 adults. Find the probability that the number of adults who say they have cheated on an exam before is A, exactly 4, B, more than 2, and C, at most 5. So we'll start with part A. So the first thing we have to do is decide which distribution to use, geometric, Poisson, or binomial. Well, here, there's 2 choices. The person either says they cheated on the exam or they don't. So that makes this binomial. We're going to use the binomial probability formula. We need to know our value of P. P is the probability that somebody says that they did cheat on an exam, which would be 0.56. Q is the probability that they didn't say they cheated on an exam, which is 0.44. The N value is how many people we've selected, which is 7. And in part A, the X value is 4. So our binomial probability formula is probability of exactly X successes is NCX, P to the X, Q to the N minus X. If we plug in these values, that's probability of 4 is 7C4, 0.56 to the 4th, 0.44 to the 7 minus 4. 7C4 has a value of 35, and then 7 minus 4 in the exponent is a power of 3 on the 0.44. We multiply this out with our calculator, and we get 0.2932095975. Rounded to 3 decimal places is 0.293, and that's your answer to part A. For part B, we're looking for the probability that more than 2 say they've cheated. We want to use the binomial CDF formula on the calculator. This formula allows us to take the binomial value for several different values of X and add them together all at the same time. So here the probability again, P is 0.56, Q is 0.44, N is 7, and the X is 2. Why 2? Well, binomial CDF always adds binomial values starting at 0 and going up to the point at which you want it to stop. Because this sum for more than 2 would be 3 plus 4 plus 5 plus 6 plus 7, those probabilities added together, and that sum doesn't include 0, what we're going to do is we're going to add up the probabilities from 0 to 2, which would be the probability of 2 or less, and then subtract that from 1, and that'll give us the probability that X is more than 2. Probability of 2 or less is something we can do with a binomial CDF. It's binomial CDF of 7, 0.56, 2. If we use the calculator to get the binomial CDF of 7, 0.56, 2, that's 0.1402447569. When we do our subtraction, 0.8597552431, rounded to 3 decimal places, is 0.860. That's your answer to part B. For part C, we want the probability of at most 5. Well, think about what at most 5 means. At most 5 means 5 or less. 5 or less would be all the X values between 0 and 5. Because this value does include 0, we'll use the binomial CDF, but this time we don't have to do a subtraction. So we still have the same values for P, Q, and N. Now the X value we're going to use is 5, because that's the last probability we want included in our sum. So the probability of at most 5 is the probability that X is 5 or less, which would be binomial CDF, 7, 0.56, 5. Plug that into your calculator, you get 0.88773888348, rounded to 3 decimals, is 0.888. And that's your answer to part C. The last question asks, which of the events are unusual? Select all that apply. Well, the criteria for being unusual is to have a probability less than 0.05. None of these probabilities in part A, B, or C were less than 0.05, so none of the events are unusual, and that's answer D. And that's your answer.